Thank you, Dean LaForte, for the introduction and for all you do for UNA, your faculty, your students, and the community. I value your leadership. Can we get a round of applause for our culinary arts students and our culinary arts faculty? I think we very much enjoy all your refreshments and food here today. Good morning and welcome. We are very pleased and honored at the University of North Alabama to host this important conference. We hope that you have a wonderful experience on our campus and in the Shoals. Thank you very much for partnering with us with what we hope is the first of many return visits for this conference. As a university, we are committed to STEM education and the development and training of the next generation of educators in this critical field. I thank and commend all of you for the dedication and passion you exhibit towards your students in the classroom every day, and also in the community as you advocate for STEM-related issues and causes, which is often not the easiest endeavor. I understand that very, very well. Again, thank you so much for attending this conference and traveling to the University of North Alabama, Florence, and the Shoals. We are quite pleased to host you. Thank you and enjoy Roar Lions. Have a great day.
Thank you. Wow. I tell you, you got them excited. We're not going to start going on the road, tie, or even all that stuff. We may get some fights in here and what have you. Although there's some people probably happier to shout than others. But again, thank you all so very much. Everybody has a copy of the program, right? Forgot to tell you all, we have a program, and as my pastor has said often, we'll follow it as printed, okay? At this time, I am honored to introduce to you all, got to have these, Dr. Don Thomas. Dr. Thomas is an astronaut, a former astronaut. I think you fired, you keyed up. All right, don't shoot off yet, okay? He's a former astronaut and from Ohio, well-educated, Cornell University, has worked with cosmonauts, astronauts throughout the world, has flown into space several times. You know, I told him this morning when I met him for the first time, I said, I probably had not an opportunity to shake an astronaut's hand. And I said, is it for real that all astronauts say the first time they go up and they look back? And he said, it's for real. It's beautiful. But we're so honored to have him. But most importantly, when I was reading his bio, I want you to know not only has he had the opportunity to work with astronauts, cosmonauts, what have you, he's now working with STEM schools, working with students, making that connection, and we're just so honored to have him here today. So let's give him a warm welcome as he comes to the stage. Dr. Don Thomas. Let's give him a warm
Thanks. Hey, good morning, everybody. Hey, I'm so happy and honored to be here today. I want to thank Candy Garner from Winfield Schools. I met her this summer at the Air and Space Museum doing a talk. She invited me to come to the Winfield Schools to talk to the teachers there in August, and then just a few weeks ago, I talked to all the students in that district, and we had a great day there. It was a wonderful opportunity, so I thank you for making that connection. Well, I'm really honored to be here today. I want to start off by telling you a little fact. If you asked 100 astronauts what career do they respect the most, you'd always get one astronaut who would say, well, astronauts are the most impressive, because we deal with some big egos in the astronaut office. But the other 99 out of 100, you ask them, what career do you respect? And 99 out of 100 of those astronauts would tell you they respect teachers the most. You guys are at the top of the list, because we know you represent the future. Krista McCullough, our school teacher who perished on the Challenger accident back in 1986, she used the phrase, you know, I touch the future, I teach. And that's exactly what each and every one of you do here today. And there's nobody that respects your job more than the astronauts. I just want you to know that. We have great respect for the work that you do, because we know that our future of our country, of our planet, is in your hands. So I just want to pass along that respect, and it comes from all the astronauts that have ever flown in space. They would tell you the same thing. except for that 1 out of 100. So what I'm going to do this morning, I want to share with you a little bit about, talk about the role of inspiration in education. And this is a personal story. I'm going to tell you about my background. I'm going to tell you a little bit about what it's like up in space just for the fun of it. And then at the end, I'm going to talk about the importance of STEM and why your mission here is so vital to our country, to our planet, to our society here. So with that, I'll go ahead and get started. Now, I always start with this picture. This isn't a picture of me, but it very well could have been me. I was 6 years old when the first American astronaut launched into space. That was a long time ago, May 5th, 1961. And at my elementary school in Cleveland, Ohio, where I grew up, they brought all the students to the gymnasium. I sat on the floor. I watched a small black and white TV that day of the launch. And as soon as our astronaut was in space, I remember sitting there saying, I want to do that. You know, I had no idea what astronauts really did. I didn't know how to become an astronaut, but I knew that is what I wanted to do. It really set a spark in me that day. The next year, when I was in first grade, John Glenn was the first American to orbit the Earth. And again, they brought all the students to the gymnasium, watched his launch, and as soon as he was in orbit, we went back to our classrooms. And my desk was right along the windows in first grade. And I remember getting back to the classroom, and I sat there the rest of the morning, not listening to the teacher, looking up front. I was looking out the window, hoping to see John Glenn passing over Cleveland, Ohio. Little did I know he did not even pass over Cleveland, and even if he did, I wouldn't have been able to see him. But I was hooked at that young age. And I didn't know how to become an astronaut, but the one thing I recognized really early on was it's really difficult. It's very competitive. Thousands of people apply to become an astronaut, and then NASA selects just a small handful of people, individuals. So I knew the only shot that I would have of becoming an astronaut would involve me working hard and doing my best in school every single day. In all my subjects, I knew I had to be good at math and science, but I worked hard at reading, history, music, art, gym. Whatever I was working on, I always tried to give it my best effort. In elementary school, I was just an average student. Got mainly B's, and a few C's, and a few A's. When I hit middle school, I was more focused, working a lot harder on my schoolwork, and I was getting A's and B's. And then by the time I got to high school, I was really focused, really working hard, and I had nearly straight A's. I had 1 B in high school and the rest A's. And I got those grades not because I'm the smartest guy in the world, not by a long shot. I got those grades because I worked really hard. I have a fraternal twin brother who's like a genius. He never had to study ever, and he got straight A's like that. And I know you have students in your classrooms like that, and many of you are like that as well. Well, I was one of those students that had to read the chapter, read it again, go talk to my teacher or professor, study some more, but in the end, I learned everything I needed to learn. And I learned how to work hard along the way, which was a great skill later on in my career. Well, after high school, I went on to college. I went to Case Western Reserve University in Cleveland, Ohio, where I grew up there. Got my bachelor's degree in physics, and that's the minimum degree you need to become an astronaut. 4-year college degree in math, science, engineering, and the medical field. But again, I knew it's going to be very competitive, and I couldn't go into the competition with just the bare minimum requirements. So I decided I'm going to see if I could stay in the university and get my master's degree. I went on to Cornell and got my master's in engineering. And after 2 years then, I finished that, and I thought, well, let me just stay in school a few more years and get my PhD. I wasn't sure I could even accomplish that, but I decided I'm going to, make a go for it. And after about 5 years, I graduated from Cornell with my master's and my doctorate in engineering. So after about 9.5 years of college, I got out, and I took a job with AT&T Bell Laboratories in Princeton, New Jersey, doing research work on semiconductor materials, their electronic devices. And this was in the early 1980s, just about when NASA was starting the space shuttle program. So my timing turned out to be perfect on all of this. And NASA selects new astronauts every 2 or 3 years. They'll pick a small group of 10, 15, or 20, depending on their needs. It was 2 years after I got out of college, NASA made an announcement they were looking for new astronauts. I was all excited. I wrote to NASA. I got the application form. I filled it all in. I mailed it back to NASA. And I never heard back from them. Nothing. It was about 8 months later, I was reading the New York Times, and there was a little article in there. And the headline said, NASA selects 15 new astronauts. And I thought, well, that's kind of strange. They didn't call me. And I read that article, and my name was not on that list. And that's when I realized this was going to be a lot harder than I ever thought it was going to be. I thought by working hard, doing well in school, getting good grades, going to good universities, working for a great company, I thought I'd be a shoo-in, but that definitely was not the case. Well, I decided I'm not going to give up, I'm going to try again. And 2 years later, there was another astronaut selection. I got another application form, mailed it back in, and this time I heard back from NASA. I got a little postcard. And it started off saying, "Dear Sir and/or Madam, you know where we're heading with this. Thank you very much for your interest. We had a lot of good candidates. We didn't select you, but good luck in the future." And I looked at that postcard and I thought to myself, my grandmother and I have the same chance of becoming an astronaut. That chance was 0. I wasn't even getting close in the competition. So at this point I decided I need to do more to get noticed by NASA. And being an engineer, what I did was I studied the data. I went and looked at who are they selecting? What are the backgrounds? What education? What experiences did they have that I didn't have? And I thought maybe by studying that I could make myself a better candidate, model my careers after those who were successful to get into the program, and I thought maybe that'll help. So I studied all that and I noticed a few things. First off was most of the civilian astronauts NASA was selecting, they already had some flying experience. It wasn't a requirement by NASA, but it seemed to help a little bit. So I took flying lessons, got my pilot's license and my instrument rating. Most of the astronauts NASA was selecting had some skydiving or parachuting experience. It wasn't a requirement, but again, it seemed to help a little bit. So I learned to do that. I taught a university course, because that seemed to be experience NASA was looking for. I learned to scuba dive. So I worked on all these things, hoping that maybe each one only counts for a little bit, but maybe all together they'll add up and I'll be head and shoulders above the other candidates for that next selection. So I worked on all those items, and it was 3 years later there was another astronaut selection. I sent my application in, and this time NASA called me up and they invited me down to the Johnson Space Center in Houston, Texas for a week of medical testing and an interview. And out of the thousands of people that apply, NASA will whittle that down to 100 individuals. They bring you to Houston and you spend a full week on a very thorough, exhaustive medical exam. And then there's a 1-hour interview after that. So I went through the week of medical testing, passed all the medical tests, went on to the interview, and I gotta tell you, I was sitting outside the conference room for the interview, and I could not have been more nervous. I was just sweating, I couldn't even remember my name. I'm just sitting there thinking, how am I gonna get through this interview? There's so much writing on this 1-hour interview. And they opened the door of the conference room, they said, "Hey Don, we're ready for you." And it was like a magical peace came over me. And I said to myself, "Don, this is your chance, you know, to tell them why you would be a good astronaut." And a peace came over me, went into the interview, and it was 1 hour long. It went extremely well. When I walked out of there, I thought, wow, that couldn't have gone any better. And at the end of that week, I went back to my job in Princeton, New Jersey, and just sat there and waited to see, did I make it or not? And I was back at my job for about a week or so, and some of my friends started calling me up from across the country. And they said, "Hey Don, the FBI's been calling about you." Let me tell you, if the FBI's ever calling about you, it's either really good or really bad here. In this case, it was really good. NASA was doing a security background check on me, and they looked into my past. They went and met with every employer wherever I worked from high school on. They would go to my former bosses, each and every one, and say, what kind of worker was he? How did he treat the coworkers? How did he treat the customers? Did he show up to work on time? They went up and down the streets wherever I lived from high school on, talking to the neighbors on either side, asking, what kind of person, what kind of neighbor was I? How did I treat people in the neighborhood? Was I always out late partying at night, or was I home studying, you know? And then they would stop random people in the neighborhood, just asking about me. So they were looking for dirt. And it was, you know, when I first heard they were doing this, I thought, this is a great sign. I didn't think NASA could be doing this really detailed security check with all 100 people they were interviewing. I really thought they must have selected their astronauts and this is the final security check to make sure you're good to go before they announce the names. So I was pretty excited, and it was about a month later I got the phone call from NASA. They said, Don, thank you very much for applying. We had a lot of good candidates. We didn't select you, but good luck in the future. And I hung up that phone and I was devastated. I cried for 10 minutes because they had just broken the dream, the heart of a little boy. You know, I think I was 32 years old at that time, but it was really devastating news. And at this point I decided I need to give up on this silly dream of mine. I worked hard, I did my best, you know, but it was time to move on. And I felt like I was getting a big message from NASA. We don't want you. You know, after being turned down 3 times, first time no, second time no, the third time they interviewed me and got to know me, but the result was the same, they said no. So I decided it's time to give up on this. So I thought I'd go to bed, I'd get a good night's sleep, and then in the morning when I woke up, I would put together a new plan for what I'm going to do with my career. Went to bed that night. The next morning when I woke up, the very first thought that popped into my head was, I still want to be an astronaut. So I asked myself again, is there any more of these little things that I can do to make another go, make another shot at it? And again, by looking at the numbers, I noticed that most of the civilians, astronauts that NASA was selecting, most of them were already working at one of the NASA centers. And most of them were working at the Johnson Space Center down in Houston. Again, it wasn't a requirement, but the vast majority of the civilians they were selecting were already working at NASA there. So at that point, I decided I got to quit my job. I went into my boss, and I was just a few weeks short of getting vested for retirement. I was just a few weeks short of getting my 3rd week of vacation. And I told my boss, I'm quitting. I'm going to drive down to Texas. I got to chase this dream. And everybody at Bell Labs there, most of my coworkers thought I was nuts, you know. But I said, I got to do this. You know, for me, I gotta do it. So I drove down to Texas. I got a job with Lockheed Martin, one of the contractors for NASA, working as an engineer on the space shuttle program. I did that for 3 years. Then there was another astronaut selection. Sent my application in. I got called up again for the medical testing and the interview, so I made that group of 100 semifinalists. The medical testing all went well. The interview went well again. And then this time, it was about 2 months later, I got another phone call from NASA. And this time when I picked it up, they said, Don, are you still interested in being an astronaut? Because we'd like to offer you the job. And I said something really intelligent. This is quotable. I said, habita, 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 habita. I finally got the words yes out of my mouth, and I hung up the phone, and I was jumping up and down, yelling and screaming for 10 minutes, because I knew I had made it into the program. I was in the queue. I didn't know when I would fly, if it was going to be in 5 years, 10 years. There's no guarantee on any of that. But I knew I had made it in. I'm in the line. I'm in the queue to go into space. It was really an exciting phone call to get. I was 35 years old when I got that call, and I started a 4-year training program for my first flight. So the first time I actually made it to space from dreaming about this as a 6-year-old was when I was 39 years old. I tell that to students. I say 39 is like an old man, right? And they're like, oh yeah, that's way old. So I think Winfield students were very, very polite and said, well, that's not that old, Mr. Thomas. But you know, some of the careers our students will pick, it takes time to get there. And this all comes back to that moment of inspiration, okay? It took a lot of inspiration for me to go through all that, to keep coming back at it. But that's what that moment does for you when you find yourself inspired as a student. And that is what you do every day in the classrooms. Whether it's a field trip, whether it's a book or a chapter you're reading at school, something new for the students. Whether, you know, there's a movie you watch together. Whatever it is, you are inspiring your students every single day. And I just want you to know how powerful that inspiration is, because you cannot turn it off. For most students, once you turn it on, you cannot turn it off. And the results can be really impressive. Like, nobody had to push me. Don, study harder, make sure you get your homework done. I was going for it. I had good support at home. My parents got divorced when I was about 9. My dad took off. He was not a part of my life, but I was fortunate to have a loving mom who provided a very loving environment in our home. And I felt that support at home. but then I had this inner drive, this inspiration to help get me going through it. And I finally went on to fly on 4 missions, 4 times. I was on Space Shuttle Columbia 3 times and Space Shuttle Discovery once. I've spent a total of 44 days in space, and during that time I went around the Earth 692 times. So I can stand up here and confidently say, you know, I've flown over your school districts on many occasions here. This is the crew from my last flight, and the last time I was in space was 20 years ago already. It makes me old to say that, feel old to say that, but this is the crew from that mission. We've got 2 military pilots here in the front row that help us fly the shuttle. This is Jim Hulsell, our commander. He was an Air Force test pilot, used to fly the SR-71 Blackbird spy plane. Our pilot in the mission right here is Susan Still. And Susan was a pretty unique individual. She was only the 2nd woman to pilot the space shuttle. And Susan was one of our country's top Navy fighter pilots. So it was a great opportunity for me to fly with her on this mission. And then we had 5 science astronauts. We're called mission specialists and payload specialists. Our job is to do the science on board. We work the robotic arm on the shuttle if there's a need for that. We deploy satellites and do spacewalks. So we each have our area of specialty on the crew. You probably don't recognize that guy right there, but that's what 20 years has done to me. And I tell people this is the result of space flight. That the wrinkles and the gray hair and the glasses, that's all from flying in space and having a teenage son who grew up. So there's the shuttle on the launch pad. I took this picture the night before my first mission. Went out there about midnight or so with another one of the astronauts. It was so incredible to stand there right at the base of your space shuttle, all lit up with those bright lights against that pitch black sky. And as I stood there gazing up at it, I had incredible butterflies in my stomach. You ever get butterflies? Maybe before the first day of school, I'm sure before your first day of teaching you felt this, but I was a little bit nervous, a little bit scared, but mainly really excited because I knew in 12 hours I'm going to be sitting inside this thing blasting off. And I almost couldn't believe where I was and what I was about to do. So this big orange tank, this is our big fuel tank. It holds 500,000 gallons of liquid oxygen, liquid hydrogen that feed 3 engines at the tail of the shuttle. We've got 2 side rockets called solid rocket boosters. They have a solid propellant like gunpowder packed into them. They burn just for the first 2 minutes of the flight. And then the space shuttle itself. If you've ever driven over to the Space and Rocket Center, you'll see they have a space shuttle mounted there. You'll see how big it is. It's about the size of a commercial airplane at your local airport. And it's a huge vehicle. And as big as a shuttle is, it's only this tiny section in the nose right there. That's the only area that's pressurized for the astronauts to live and work in. It's a very small area, maybe about the size of your kitchen at home. And that's where 7 of us would spend 2.5 weeks in space. And then below that is our payload bay or cargo bay where we carry our equipment to space. It's a huge vehicle, 65 feet long. We could easily put a school bus in the back there and launch some of your students to space. I'm sure you'd like that for some of your students, right? But we've carried up huge satellites like the Hubble Space Telescope. We built the International Space Station with components, many components that were launched in the back of the space shuttle. So they bring the astronauts out here on launch morning, and this is another incredible moment. 3 hours before liftoff, the bus drops us off right at the base of your space shuttle. And to stand there, you'll see some condensation from the liquid oxygen and from the engines flowing through there. And again, just to stare up at that vehicle one last time before you climb on board, it's another butterfly moment. And when you come out here on launch morning, it's a little different than any other trip you've had out to the launch pad. Because on launch morning, when you get out here, the first thing you notice is, hey, where is everybody? Out at the launch pad, there's always hundreds of engineers and technicians that are working on the shuttle, getting it ready for launch. You come out here on launch morning, and there's nobody there. There's a handful, maybe a half a dozen people that help strap us into our seats. They do last-minute inspections, a few safety people there. Once we climb on board, that they get out of that area. But that's that first thing. It's like, where is everybody here? And we take an elevator up, and there I am standing in front of Space Shuttle Columbia. They strap us into our seats one at a time. So I'm just outside here waiting when it's my turn to get strapped in my seat. They'll call out and say, hey, Don, we're ready for you. I'll turn that corner, walk down that access arm, and they strap us into our seats. And it's about 3 hours later, they light the engines and you're on your way. And I gotta tell you, on my first mission, I'm laying on my back. I could hear the roar of the engines as they come up to power. I could feel all that shaking and vibration going on. And right when these 2 solid rocket boosters lit, that's when we're finally on our way. I could feel that push in my back. And it felt to me as if somebody had their hand right in the middle of my back, and that they were just pushing me up into the sky. And once I felt that push, I knew I was on my way. I was hoping I'd make it all the way to space, but I knew I'm on my way. Here was the dream of my life taking place right in front of my eyes. It was one of the most incredible moments I've had in my life, just to see that flashing in front of your face, knowing that this is coming true right now, and I can see that. So I had my helmet on, visor down, nobody in the world could hear me. And what I'm doing, I'm screaming inside my helmet, "Yahoo, let's go!" as we launched off the launch pad. And there were 3 other astronauts on this crew that were flying for the first time. And I would pretty much bet that they were screaming inside their helmets also. I couldn't hear them, they couldn't hear me. But to feel that push, to have that dream taking place right in front of your eyes is really an incredible moment. We launch off the launch pad. 8.5 minutes later, the engines shut down, and you're in space. It only takes 8.5 minutes to get to space. Bet it takes many of you more than 8.5 minutes to get to work in the morning, to your schools, or find a parking spot. When I was at a university working, it took me more than 8.5 minutes just to get a parking spot. But 8.5 minutes after liftoff, engines shut down and you're in space. Really amazing. And at this point, we're traveling at a speed of 18,000 miles an hour. 18,000 miles an hour is 5 miles a second. So I know a lot of you have traveled across Alabama to get here today. Imagine how fast you can get home at 5 miles a second. For you, those of you in southern Alabama, you'd probably be home in maybe 30 seconds or so, or maybe a minute it would take you to get home. And we go so fast that we orbit the Earth, we go all the way around in only an hour and a half. On 3 of my 4 missions, we had a science laboratory in the back of our space shuttle. It's called Space Lab. And these missions were all managed out of the Marshall Space Flight Center in Huntsville. So for these 3 of my 4 flights, I spent a lot of time in Huntsville training for these flights there. I have a lot of friends in Huntsville. That's why I like coming back to Alabama. It's a great, great state. And on these 3 missions, we had the science module, very similar to our modules up on the space station today. And once we got to space, we would open up a hatch, float through that tunnel, and we would go back there and work on a wide range of different experiments up there. And typically during a 2-week, 2.5-week mission, we'd end up working on 150, 200 different experiments. I just want to tell you quickly about 2 of these to give you an idea for some of the science we do up there. I think everybody's familiar with the shape of a candle flame here on Earth. It comes up to a point, and the reason it comes up to a point is because here on Earth, with gravity, hot air rises. Cold air settles down. It's called convection. Hot air is lighter, and it'll rise up. Cold air is more dense, heavier, and fall down. And it's that hot air rising around the candle flame that draws the flame up to a point that you're so used to seeing. Well, in space, without gravity, hot air doesn't rise. Cold air doesn't settle. So instead of a flame coming up to a point, in space, the flame will burn perfectly round. And what you're looking at in this picture is a little pink droplet of butane fuel there in the center. It's like what we have in a disposable lighter. And we've set it on fire, and that blue ball or halo you see there is the flame burning. And it'll just float in the air. It'll burn perfectly spherical. It'll consume all the oxygen around itself, and then the flame will go out. And scientists study things like this. They're trying to understand some of the basic fundamentals of combustion. How do things burn? And what happens when we get incomplete combustion, when we have soot particles and other pollutants? And maybe from these experiments in space, we can improve our burning processes, here on Earth for our power plants, our automobiles, things like that. We also do a lot of life science experiments, biology experiments. This is an experiment with a Japanese red-bellied newt, like a salamander. And it would lay eggs. We'd put the eggs in little chambers there and just watch how they grow and develop in 0 gravity. And they look very similar to me, like frog eggs developing into tadpoles and baby frogs. You'd see gills forming in arms and legs and tails. And we just looked at them, photographed them every day, looking for anything unusual. And what the scientists were looking for specifically in this experiment was the gravity sensor, how that grew in space for the salamander. They have a gravity sensor called an autolift, and that's what they use for sensing it. They wanted to know, how does that autolift grow in zero gravity? And they learned that after a 2-week mission, almost 3-week mission, that autolift was twice as big as it would have been here on Earth had it been growing under normal Earth conditions. So it was as if it was trying to sense gravity and it couldn't, so this autolift kept growing larger and larger. So we do a lot of experiments like this in space. They also do a lot of experiments on the astronauts. We lose our muscle strength, our bone density in space. So they're always trying to figure out ways to keep the astronauts healthy for longer and longer periods of time in space. This is Chaki Mukai, the first Japanese woman in space, and I flew with her on my first mission. And in space, you don't walk around like we're used to doing here on Earth. When you want to move around in space, it just takes a little push with your finger, and you sail through the air like Superman or Superwoman. And you keep sailing until you hit a wall or until you reach out to stop your motion. And if you like doing somersaults, you can start flipping in the air, and you go round and round all day until you get tired, and you reach out to stop your motion. So what do you think? Does it sound like fun up there? I could see all of you floating around up there. This is Susan, our pilot. She's typing on a laptop computer right there. And I want to point out one feature. You see how she's got her toes hooked on that vertical gold pole on the left-hand side? If she didn't do that, every time she hit the keyboard on the computer, what do you think would happen? She's going to bounce off in the opposite direction. One of Newton's laws, right? For every action, there's an equal and opposite reaction. But if she just anchors her toes a little bit, she can float in the air, stay in position, and type on the computer all day long. So space is a really fun, comfortable environment to be in. In space, we don't have a refrigerator, a freezer, a microwave oven, nothing like that. So all of our food is freeze-dried, and it comes in small plastic packages. It looks like camping food. And to prepare a meal, we bring it to this food station. There's a needle that'll poke into that package. We inject our hot water, and that dry, hard food absorbs the water, softens up, and after a few minutes, it's ready to eat. I tell people the food up in space, it's okay at best. I would never go to a restaurant that serves space food. So don't do this for the dining experience, but there's a great view out the window that I'll share with you here in a minute. And sleeping is a little different. The inside of the space shuttle was pretty small, about the size of your kitchen at home, and we didn't have dedicated bedrooms. So when it was time to go to bed, we would just take a sleeping bag, attach it to the wall with a few clips, then you just float up there, slip inside, zip it up, and you go to bed. We wear the dark eye shades because we go around the Earth every hour and a half. You get 45 minutes of daylight, 45 minutes of nighttime. If you don't want the sun coming in your eyes all the time, you need to wear the eye shades. We have these dark blue straps around the waist. We can tighten those straps up, and it'll pull your back up against the wall of the shuttle. And it puts a little pressure on your back to make you feel like you're laying on your mattress at home, here on Earth. Because if you're just floating in the air sleeping, it feels really strange. So for the first couple of days, we tighten up those straps, pull your back up against the wall, feels a little more normal. We also have an elastic strap that goes around your forehead that'll pull your head into a pillow, just to put some pressure on your head. Because again, it feels a little strange when you're sleeping, your head is just floating there. So we do these things. After 3 or 4 days, you can loosen the straps. You feel pretty much adjusted up there. But we'll still stay inside of our sleeping bag and kind of float there sleeping, because there's fans that circulate the air, just like we have in here. There's air intakes. And if I was just floating in space, sleeping slowly over time, I would go to one of the air intakes, bump my head and wake up, or kick somebody along the way and wake them up as well. Now, exercise is really important in space. As I stand up here in front of you today, I'm using my leg muscles to walk around, fight gravity, but in space, a little push with my finger and I just sail through the air. And everything is weightless in space. I can lift one of these tables with one finger. I can lift your car with one finger. So in space, we don't use our muscles at all, and it's very important exercise. So on the space shuttle, we had a little bicycle that you see here. We'd ride this for about 45 minutes a day. Get your heart muscle going, get your leg muscles working, so that when you come back to Earth at the end of the mission, you're still in decent shape. For our astronauts up on the International Space Station, they exercise for 2 to 3 hours every single day. And that's a huge amount of exercise, but they still come back with weakened muscle, weakened bones. So we're still trying to figure out ways to keep our astronauts healthy in long periods in space. During the 45 minutes that I would ride this bike, we would travel halfway around the world during that time. And it was always amazing. You're pedaling the bike and I could lean back And right above my head, there was a window of the shuttle. So as you're pedaling the bike, you look out the window and maybe you see Australia goes by, or Africa goes by. And some of the astronauts used to make a big deal about it. They would say, I want to bicycle across the Pacific Ocean. If you ever hear that claim, don't be too impressed. It only takes about 15 minutes. I want to show you some of the pictures of the Earth from space. And whenever an astronaut has a free moment, we would float to the window to watch the Earth go by. I've got this map in my hand here. I'm trying to figure out where we are around planet Earth. And I'm looking out one of the windows there towards the tail end of the shuttle. And I took a camera right up to that window, pressed it against the glass, and I took a picture so you can see exactly what my eyes are seeing. And this is the view I get to see out the back. So there's the Earth from 200 miles above. All the blue in this image here is the Pacific Ocean. The white area are puffy clouds. These clouds are 5 or 6 miles above the Earth, and again, we're flying 200 miles up, so we're well above the atmosphere. This is Baja, California, looking south. So San Diego, California would just be to the upper right-hand corner of that picture. And if you look carefully here at the bottom edge of the Earth, you'll see a little thin blue line either to the right or to the left of the shuttle. And what that blue line is our atmosphere. You know, on a nice sunny day like we have today in Florence, you look up at that blue sky, it looks like it goes on forever and ever. From space, we see the atmosphere edge on. And it looks just as you see here, it looks like a paper-thin layer. And, you know, it really makes you appreciate how fragile planet Earth is and how we have to take better care of our planet. Here's another image, a little zoomed in, but you see that little thin blue line there. And on my first mission, as Andre pointed out, I went to the window as soon as we got to space. I looked out at our planet and I just gasped. It was like, oh, wow, look how beautiful our planet is. It makes every astronaut gasp that first time you see it. And the one thing is to see how thin our atmosphere is. And the second thing that was amazing to me was how black the sky is. I've done caving, spelunking around Huntsville. That's the spelunking capital of the world. I didn't know if you knew that. But there's a lot of great caves here, and I've been caving. We shut off all of our lights, and it's pitch black. But I think the color of the sky in space is a darker black color than anything I've ever seen. It's almost like a velvety black, almost like it was glowing black, like a black fluorescent light glowing like that. And to see that pitch black sky and that thin atmosphere glowing like a fluorescent blue, just such an incredible sight from space. Here's a big hurricane. I saw many storms when I was up there. This was a big hurricane over the Pacific, and this one was about 400 miles across. And we flew right over the eye of it right there. And from 200 miles up, I could go to the window, look straight down, and look right into the eye of the hurricane and see the blue water of the Pacific Ocean. The next picture will show you that eye looking straight into it from directly overhead, right there. It's about 15 or 20 miles across. You see why they call it the eye here. Very light winds in the center, just a few mile-an-hour breeze, but 7 or 8 miles away, this is the eye wall right here. And this one had top wind speeds of about 135 miles an hour, so a really strong Category 3 hurricane. Here's a volcano, vending steam. This is in the South Pacific near Indonesia. Volcanic crater here, half underwater. These are all volcanic islands in that part of the world. We were flying over the big island of Hawaii in one of my flights. And they do a really good job of not having a lot of city lights to protect their telescopes that they have on top of one of the mountains there, volcanic peaks. And I'm looking out the window and I see the island, but I see this red, looked like a red river glowing down there. And at first we're all at the window like, what's going on down there? What are we looking at? And it finally dawns on you, that's hot lava coming from Mount Kilauea. So you see some of these sights and you just say, wow. I can't tell you how many times I looked out the window and just said, wow, when I was in space. Here is the Himalaya Mountains, and right here at the very center, this is Mount Everest. And right there is the very top of Mount Everest. Now, I can stand up here in front of you today and tell you without lying, I have seen the top of Mount Everest with my own eyes about 25 times during my missions. This is a tough crowd. I sense you're not impressed by that. I call it the lazy man's way to see the top of Mount Everest, right? No climbing involved, just cruising overhead at 18,000 miles an hour as I drink my juice. But I use this picture to illustrate some of the things I got to see and do during my career. I've never climbed Mount Everest, never will in my lifetime, but I've seen the top of it many times. I've seen the Great Barrier Reef off Australia, the Amazon rainforest in Brazil down in South America. I've seen Mount Kilimanjaro, big volcanic peak in Africa poking up through the clouds. So many amazing sights around planet Earth. This is one of my favorite parts of our planet. This is out over the Mediterranean here. So here's the Mediterranean, the Nile Delta, the Nile River cutting through there. There's the Red Sea. You see the city of Cairo. Cities show up fairly gray from space. The pyramids of Egypt right there. And when you look at the Nile River itself is only about half a mile wide, quarter mile wide. But what you're looking at here is maybe a 20-mile wide band where they're doing irrigation all along the Nile River there. My favorite part of this picture is up here in the upper right-hand corner. This darkened patch that you see right here is the country of Israel. And if you look really carefully, you can actually see the border between Israel on the right and then Egypt on the left. And I'm going to zoom in on that area right here. And again, this is in the Sinai Peninsula. On the left-hand side, just Sinai Desert there in Egypt. On the right-hand side here, in Israel, they're doing a lot of irrigation. All these little patches you see here are where they're growing crops there. And just because they use their land differently, you can see this very distinct border with your eye from space. You'll frequently hear the phrase, oh, there are no borders from space. There are about a handful of these as you orbit the Earth, you look out and you see these straight lines. Down in South America, I think one country, I can't remember which one, Colombia, one of them is protecting the rainforest when the neighboring country is just cutting it down. And you see this very distinct line. Rainforest here and nothing on the right-hand side. Anybody recognize this beautiful part of planet Earth? You gotta look carefully there. Let me put a few cities on here to see if that helps here. So there's Tuscaloosa here, Birmingham, Montgomery, Florence, and UNA. I think you can just barely see. Beautiful, beautiful city. Decatur's right over here. Huntsville, I think, could be right here, but I think it's right off the top of the map here. It's just beautiful to see our planet. Wherever you're flying over, it's a different part of our world, and just spectacular to see from space. And this is a sunrise from space. Because we go around the Earth every hour and a half, we get to see 16 sunrises and 16 sunsets every 24-hour day. And they're all a little different depending on volcanic dust and clouds. And again, when you watch one of these from space, you see how thin our atmosphere is. The edge of the Earth is down here where it's darkened. These thin black lines you see, these are the tops of old thunderstorm clouds, maybe 10 miles up or so. So you see our atmosphere, most of it is in that first 20, 25 miles, and that is about it. At the end of the mission, then it would be time for us to come home. We would fire 2 engines in the tail of the shuttle. It would slow our speed down from 18,000 miles an hour to about 17,000 miles an hour. And it sounds like we're still going fast, but at that speed, gravity takes over and we begin our fall back to Earth. We'd fire those engines halfway around the world over the Indian Ocean. We would fall as we cross the Pacific, fall as we cross the United States. We would end up landing right back at the Kennedy Space Center in Florida, touching down like an airplane, deploy a drag parachute to slow us down, and then we just put the brakes on and roll to a stop. And then we just sit there and wait for them to open the hatch so we can get out. And typically it takes them about an hour before they open the hatch and we can come out. And when you first come back from space, you feel like you weigh about 2,000 pounds. Because you've been floating around weightless for 2 weeks, and then suddenly you come back to this pull of gravity. Just a normal pull we all feel in here today, but it felt so heavy for me. My arms were heavy, my legs were heavy, I was a little dizzy when I got back. And it took about a day or so for the dizziness to go away, and maybe 3 or 4 days later to get your muscle strength back, and then you're pretty much back to normal again. So this picture was taken maybe 2 hours after I landed on my first flight. That's me right there. And after we took this picture, I remember I turned around, I looked up at the word Columbia, and I was just staring at that space shuttle. And I thought, what an amazing vehicle this space shuttle is. This was my house in space for 2 weeks. This thing protected me from that fiery re-entry coming into the atmosphere. And then one of the next thoughts that popped into my head was, I gotta do this again. And it's like going on a great roller coaster ride. If you've ever done that, where you get off the ride, you run around and got back on it immediately when you were younger. I still do that today. That's exactly how I felt. As soon as I landed, I thought, wow, I gotta do that again. And I went on to fly a total of 4 missions. I was with NASA for a total of 20 years. It was really an incredible opportunity, but there always comes a day when you need to leave the astronaut corps. Your years of flying as an astronaut are over. As you get older, it gets harder and harder to pass the physicals. And so sooner or later, every astronaut must leave this incredible job. When I first got selected to be an astronaut, the first month in training, they had one of the veteran astronauts came in and he gave us a briefing. And his advice to us was, plan your exit right now. This is like my first month as an astronaut, and I said, you know, you're crazy. I'm never leaving this job. I'm going to be here forever. I fought so hard. It took me so long to get here. I would never leave. But sooner or later, you must leave. And it's a really tough decision. How do you find something that tops the thrill, the excitement, the adventure of flying in space? And astronauts struggle with this. Quite a few struggle with it. Many of them go in to work with the contractors at NASA, either here in Huntsville, down in Houston, maybe Washington, D.C. But for me, I decided I'm going to head into education. When I would go around the country, and about twice a month, NASA would send me out to schools across the United States to do programs for students. And I always found that energizing for me. And my wife noticed it too. She said, boy, when you come back from one of those trips, you're just full of energy. You're all pumped up from that. I said, yeah, you know, even the job of being an astronaut is a bit of a routine. Most of the days, you know, we are not flying in space. You're in meetings, you're wearing a suit and tie, you know, many days working on it, just doing paperwork. But, you know, it becomes routine, and it would be these school visits when I would get out with young students that would remind me, this is really an amazing job. And it took the students to remind me of that. So when it came time for me to leave NASA, I decided I'm going to see if I can do something in education. I got a job with Towson University, which is one of the Maryland state schools in near Baltimore, Maryland there. And they hired me to be the director of, the founding director of the Hackerman Academy of Mathematics and Science. And this was just the STEM outreach initiative by the university. So my goals were to get K-12 students excited about math and science, to inspire it and encourage them to pursue careers in STEM. And I also did many teacher workshops trying to help energize and prepare teachers in these disciplines as well. And two of the things that I did, and I was with the university for 8 years, from 2007 to 2015. One of the things that I did school visits. I went across Maryland and went to 300 schools. Many of them I went back many times and spoke to over 80,000 students. Sometimes whole assemblies, sometimes just a small classroom, you know, of students. But I would share the experiences of being in space with them, trying to inspire that generation. One of the scariest moments of my life happened to be when I was speaking to these students here. They were a bunch of 3-year-old preschoolers, and they had these t-shirts that they had made up to look like they were cows. And to come into 3-year-olds, and they're all looking like cows, and I'm supposed to talk about space. I've never been so scared in my life. I also hosted a program called Saturday Morning Science at the university. And what we did here, we tried to bring in speakers from all the science, math, science, medical field disciplines to talk to young students about their careers. And we wanted to show them the fun side of math, science, and engineering. And my goal was, maybe there's some students sitting out in the audience and they say, I could get paid to go to Antarctica to look for meteorites. That's a career. I wanted them to discover new opportunities, maybe that they hadn't thought of before. So over the 8 years I was at the university, and these were targeted for kids in grades 2 through 8. When I started them, I wasn't sure who's going to show up. The university was a little bit reluctant. They said, well, how many people are going to come out on a Saturday to hear about science? And I said, I think we could get people out there. And we ended up drawing 400 to 500 people on a Saturday. Most of the students were in grades 2 through 8. A few younger, a few older, but that was the age range. And over the 100 programs that I did over that 7.5 years, we had about 40,000 people in attendance. Sometimes we had living history people come in, Ben Franklin, we had Albert Einstein here, Benjamin Benneker, a lot of living history ones to teach kids about the past, but also just many speakers in all the disciplines, biology, chemistry, I had other astronauts coming in, just trying to give these students exposure to a wide range of career choices. And every speaker that came in, I asked them to spend 5 minutes, how'd you get into that career? Just so the students can hear some of these stories, to know that there really is no one path for anybody going down any career, and they have to come up with their own ideas for that. So why is STEM so important? I wanted to spend just a few minutes on why this is important for NASA right now. So NASA has retired the space shuttles, as you probably all know. They're all in museums right now. And we're building a new rocket called the Space Launch System. And most of this work, much of it is being done right at the Marshall Space Flight Center, not far from where we're at right now in Huntsville there. And they're building the Space Launch System. These are the biggest, most powerful rockets ever built. So if you've ever driven by Space Camp there, you'll see the big Saturn V. They have it lit up at night. You'll see what a huge rocket that is. This is bigger and even more powerful. The engines, it's about 25% more power than that Saturn V rocket. And instead of flying space shuttles, little mini planes, what we're doing now is building capsules. And we put these capsules on top of the rockets. And the reason for this is inherently safer for the astronauts. When I was sitting in my seat in the space shuttle, I was sitting there about 6 feet away from 500,000 gallons of really explosive rocket fuel. And if anything bad should happen, I'm sitting right there, right by the fuel. Almost no chance of surviving it. But when you put the capsule on top with the astronauts there, if this rocket is blowing up, has some problems, that capsule can escape and fly away, and those astronauts can survive that, which is the reason we're going back to these capsules. The Orion capsule will hold 4 to 6 astronauts, and with these new rockets, new capsules, we're going to start launching. First test launch of the rocket will be 2 years from now, in 2019. They've built most of the components for this already. They have the engines, they've got the side boosters, the big oxygen fuel tank, hydrogen fuel tank has all been assembled. They're down, or manufactured, they're down at Michoud in Louisiana right now doing final assembly and getting all the wiring and all the computers hooked up to it. But we've got the rockets that are, this is the first one at least, that will be ready to go in about 2 years. And with this generation of rockets, these are some of the destinations that NASA is looking at. The space shuttle was so big and so heavy, it was only designed to go around the Earth, to study the Earth, to do science in Earth orbit. But there's interest now in going back to deep space. We haven't been back to the moon since 1972, 45 years ago, and there's interest in going out to deep space. And these are some of the destinations that NASA is looking at. Maybe going back to the moon, visiting an asteroid, and going on to the planet Mars, and then even beyond that in the future. So these are just some artist drawings of some of these missions. NASA's talking seriously about going back to the moon. This was on the back burner for the last couple of years, but just recently I've heard more discussion going on, like this may be the next step for NASA, is going to the moon. And the reason we go to the moon is to learn to build a base and live independent of Earth, so that when we send astronauts to Mars in the future, that we already know how to set up a base like that. Here's a mission to one of the asteroids. And NASA would like to bring back some of these samples. These are early remnants of our solar system. We think they're about 4.5 billion years old. So scientists would like to gather samples of these. And again, these capsules and rockets will allow us the capability to visit these. This is a mission to one of the moons of Mars. Mars has 2 moons, Phobos and Deimos. I think it would be so amazing to be that astronaut right there. You look over your shoulder and you've got the giant red planet Mars in the background. And about 20 years from now, we hope to land astronauts on the surface of Mars. So again, this is an artist drawing of that day. Here's our landing craft and the first 2 humans setting foot on Mars. And do you know who those astronauts are? Me? Yeah, you're not that polite. I'm too old, right? These are your students here. These are your students that are in your classroom today. And if we're ever going to do missions like this in the future, we need them to be ready for these missions. NASA's building these rockets right now. We'll have those ready. We're building new spacesuits for Mars. We'll have those ready. And we need you to get our students ready. That's what you're working on today. And again, that is why every astronaut, 99 out of 100, has deep respect for the work that you do in the classrooms today. So why STEM in general? I think you're going to talk about that a lot at the conference, but you'll hear this a lot. Increase in STEM workforce is essential to our nation's competitiveness, economic growth, and our overall standard of living. So for all those reasons, and STEM workers are the source of innovation and global competitiveness. STEM jobs are projected to continue growing. In 2010, there was a little less than 8 million people working in STEM, about 5.5% of our workforce. 2015, it had grown to 9 million, 6.1%. So STEM jobs are growing. STEM workers earn more money on average than non-STEM. And STEM jobs are really the jobs of the future that you see here. And I just pulled out one chart from the Bureau of Labor Statistics here. You'll see different numbers depending on the study, but I think the trend is the same. You look from 2005 to 2015, almost 10% increase in STEM jobs over that time, and 4.5% for non-STEM. From 2015 to 25, it's projected to grow another 10%, where non-STEM is 6.5%. So STEM has been growing in the past, and it's projected to continue growing. So this isn't just a fad we're going through. We're going to see more and more jobs in the future that are STEM related. The fastest growing occupations in the last 10 years here, you can look at the list here, and these are almost exclusively all STEM related and their salaries. Maybe the personal and home care aides, is not STEM related, but you can make a case that almost all these other positions are STEM related. This is an eye chart here, but this has the fastest growing occupations in 2014 and projected for 2024. You look at these numbers, I don't know if it's the top 24 or 25 that are listed here, they're almost exclusively STEM. Number one, wind turbine service technicians. We don't even think about that much today, but that has got great projection for growth. Occupational therapy, physical therapists, optometrists, audiologists. There's just a whole host of STEM careers that you see here. These are the ones that are fastest growing. And I wanted to throw this in too, to show you this is the average hourly earning for full-time workers working in STEM fields and then non-STEM. And the thing that was interesting to me, the most interesting, was even those students with a high school diploma or less, the STEM, if they have a job in a STEM-related field, they're going to make significantly more money than non-STEM. 60% more money for those students that are in STEM than non-STEM. And as you get to a bachelor's degree and then graduate degrees, always there's more money in the STEM field. That percentage increase goes down, but always you see you're going to make more money in STEM. It's a really good career choice from making more money. And this I found interesting. When you look at the unemployment rates for STEM versus non-STEM workers, this is from 1994 to 2015 here or so. You see our two recessions that we had here in 2001 and then the other one 2008 here. And you see that non-STEM always had a higher unemployment rate. So they both track each other well, but you see there's more of a demand, more employment for STEM than over non-STEM. So again, why is any of this all so important? Well, I told you for me, it's because I'm not going to be able to go to Mars, but I want to see us go to Mars in the future. And these astronauts that will be undertaking those missions, the scientists that will be working on those flights, the technicians getting those missions ready, are your students in the classroom today. And for me, I'm a big fan of NASA and space exploration. That's why it's so important to me, why STEM is so important. But it's not just about going to Mars here. Your students' generation, they will also be developing new pharmaceutical drugs to keep old people like me healthy. They're going to be developing fuel-efficient cars. They're going to be developing clean energy to save our planet. making new discoveries in nanotechnologies, and just inventing new things that we can't even imagine today. 20 years ago, when I was, the midpoint of my career, early on in my career maybe, we had no concept of smartphones. And just think about in the last 10 years, what has come about from that. And there's a whole host of new technologies we can't even think about in this room today. But your students are going to be the ones working on those, helping us in that next generation. So your students are the future for all of us. And your mission as teachers, your role in getting them ready for STEM careers is so vitally important. So that is about all I had for you today. I think I'm about out of time. I don't know if we have time for 2 minutes or you just want to press on. Any questions? Anybody have a question you'd like to ask? I will hang out the rest of the morning. You can come up to me if there's anything you'd like to ask. If not, it's been a great pleasure to be here today. I hope you have a great rest of the conference and a great school year. Thank you all very much.
Wow, we have lost off, you all, and we've been out of space. At least we can say we've seen those pictures. How rewarding. I have a daughter in biomedical science, Dr. Thomas. She graduates this year. I'm telling her she can get off my payroll now because she's in one of those fields that should be taking care of me. Great job, great job. How many of you all enjoyed it so far? Very good, very good. Well, we're going to let you all have a break, but before the break, I wanted to tell you all something. I've been given orders by Rebecca to make sure I do this. Your handouts, and they're all online, and of course in your packet, I've learned from being an elementary person, I also show a visual. These are the directions for downloading everything and what have you, and all the information you need. It also tells you how to connect to the wireless if you have your devices with you. So I wanted to make sure that I shared that with you all. We're going to get a break and come back around 10 o'clock. We've got a 30-minute break, right, Rebecca? And the restrooms are out there. We have food for you and everything, and we'll be back in this room starting at 10 o'clock. Again, let's give Don another hand, please. Thank you so very much. Great job. Great job. Resource right enough. Let's have a break, you all. Thank you.
I want to be more like her every day. I mean, she's just such a genius with everything. She concentrates on what she needs for everything. Pardon me, ma'am. Yes,